What if the universe itself was built by something older? What if the stars, galaxies, and the very fabric of reality weren't the beginning, but the result of technologies so ancient, so advanced, they make our greatest inventions look like child's play? The idea that our cosmos could be the product of some primordial engineering might sound like science fiction, but what if it's not? What if the clues have been hiding in plain sight all along, waiting for us to piece together the story of the universe's first architects? Think about it. Every discovery we make, from the quantum realm to the edges of the observable universe, hints at something deeper, a puzzle we're only just beginning to solve. Some scientists and theorists believe that long before the Big Bang, before time as we know it even existed, there could have been civilizations or entities wielding technologies beyond our wildest comprehension. These weren't just tools or machines, they might have been forces capable of shaping reality itself, seeding galaxies like crops in a field, or even programming the laws of physics into existence. And if that's true, then everything we think we know about the cosmos might just be the tip of an unfathomable iceberg. In this journey, we're diving headfirst into 30 of the most mind-bending theories about these first technologies, ideas that stretch the limits of imagination and science alike. From cosmic blueprints encoded in the stars to the possibility of universes created in laboratories, each theory challenges our understanding of where we come from and what might lie beyond. Some suggest that black holes could be remnants of ancient energy harvesting machines, while others propose that dark matter itself is the ghostly echo of a long-lost civilization's experiments. And the most thrilling part, these aren't just wild guesses, they're possibilities grounded in cutting-edge physics and the tantalizing mysteries our telescopes and equations keep uncovering. So buckle up, by the time we're done, you might never look at the night sky the same way again. What if the universe wasn't born, but grown? Imagine an intelligence so vast, so far beyond our own, that they didn't just discover the laws of physics, they wrote them. This is the core of the cosmic seed hypothesis, the idea that our entire cosmos could be the carefully cultivated product of a civilization wielding technologies that blur the line between science and creation itself. Picture this, a single seed, not of matter but of information, a blueprint encoded with the precise conditions needed to unfurl galaxies, stars, and eventually life. Think about the eerie perfection of our universe. The fundamental constants, gravity's strength, the speed of light, the charge of an electron, are dialed to such exact values that even the slightest tweak would render reality sterile, lifeless. Scientists call this the anthropic principle. The universe must be this way or we wouldn't be here to question it. But what if this fine-tuning isn't luck? What if it's engineering? A seed technology could explain it. A design so sophisticated that it unfolds complexity from simplicity, like a cosmic algorithm generating the universe's grand fractal patterns. Look at the structure of the cosmos, vast filaments of galaxies stretching across billions of light years, mirroring the branching veins of a leaf or the neural pathways of a brain. These self-similar patterns hint at something profound, a signature of embedded code, a hidden logic underpinning everything. If an ancient civilization could encode a seed with the rules of reality, then the universe we see might be the inevitable blossoming of their design. But here's the spine-tingling thought. If this hypothesis is true, then the architects of existence might still be out there, tending to their cosmic garden. Or perhaps their fingerprints linger in the very fabric of space-time, waiting for a species like ours to decode them. Either way, the answer to the universe's greatest mystery could be written in the stars, not as random chaos, but as the deliberate strokes of a technology older than time. Now consider this: what if the nothingness of space isn't empty at all, but littered with the debris of an ancient operating system? The void between stars hums with unseen energy, particles flickering in and out of existence in a quantum dance we barely understand. But some theorists propose these vacuum fluctuations aren't random. They're fragments of a cosmic hard drive, residual data from a universe that existed before our own. This is the spine of quantum archaeology, the idea that space itself might be a graveyard of primordial technology. Think of the zero-point energy field, that seething ocean of potential buried in the fabric of reality. Even in absolute emptiness, the universe crackles with activity, virtual particles appearing, colliding, vanishing in nanoseconds. It's like static on an old television, but what if that static carries meaning? Modern quantum computers use qubits that exist in multiple states at once, harnessing uncertainty to perform calculations. Now picture a system infinitely more advanced, one that didn't just compute but built. If a civilization mastered quantum engineering at this scale, they could have encoded the blueprint of our universe into the vacuum itself, leaving behind fluctuations as cryptic as runes carved into spacetime. The holographic principle adds weight to this wild idea. It suggests all the information in a volume of space might be stored on its surface, like a cosmic thumb drive with data projected into 3 dimensions. Black holes, those enigmatic destroyers, might actually preserve information in their event horizons, a phenomenon dubbed holographic entropy. If true, then the vacuum's faint whispers could be echoes of a previous cosmos, a failed experiment or deliberate reset etched into quantum foam. Here's where it gets chilling. If remnants of this technology linger in the void, we might already be interacting with them. Every particle collision in labs like CERN, every detection of Hawking radiation, these could be accidental glimpses into an instruction manual written in a language we're only beginning to decipher. The universe's first engineers might not have left behind monuments of stone or metal, but something far more enduring, a code woven into the nothingness, waiting for a species curious enough to read it. What if the universe wasn't built by a civilization at all, but by fragments of consciousness flickering into existence from pure chaos? Enter the unsettling theory of Boltzmann Brain Fabricators, where reality itself might be the accidental byproduct of self-aware entities emerging from the void. These aren't beings as we imagine them, no bodies, no worlds, just naked minds briefly coalescing from random quantum fluctuations, long enough to perceive, to question, and perhaps even to create. The idea springs from a haunting implication of thermodynamics. In an infinite universe, or better yet, an infinite multiverse, the laws of probability suggest that even the most improbable events must eventually occur. Given enough time, particles in a featureless void could randomly arrange themselves into a fully formed brain, complete with memories, thoughts, and the illusion of a world around it. These hypothetical constructs are called Boltzmann brains, named after the physicist Ludwig Boltzmann, who grappled with the paradoxes of entropy and order. But here's the twist. What if these transient minds didn't just hallucinate reality? What if they shaped it? Picture a cosmos where spacetime itself is littered with these phantom intellects, each one a brief spark in the darkness, warping the fabric of existence with its fleeting perceptions. Like a dreamer whose thoughts manifest as reality, a Boltzmann brain could, in theory, imprint its illusions onto the universe, stitching together galaxies and physical laws from sheer randomness. The eerie part, if this hypothesis holds, our entire universe might be nothing more than the dying dream of a mind that existed for less than a nanosecond, its chaotic neural firings frozen into the structure of everything we know. But how plausible is this? The math is both compelling and deeply unnerving. In an eternally expanding multiverse where entropy reigns supreme, Boltzmann brains should statistically outnumber real observers like us by an unimaginable margin. So why don't we see evidence of them? Some physicists argue that the very fact we're here, observing a stable, ordered cosmos, is proof the theory is flawed, or that we're missing something fundamental. Others suggest a spine-chilling alternative. Maybe we are the Boltzmann brains, moments from dissolving back into the void, our entire history just a mirage conjured by a random fluctuation. Yet there's another layer to this mystery. If Boltzmann brains can influence reality, even accidentally, then the universe might be littered with their half-formed creations, ancient, glitching structures lurking in the darkness. Imagine stumbling upon a rogue planet where the laws of physics bend unnaturally, or a nebula that seems to mimic neural patterns. These could be the scars of minds that briefly were, their thoughts etched into the cosmos before vanishing forever. So where does that leave us? Either the Boltzmann Brain Fabricators theory is a cosmic dead end, a fascinating but ultimately flawed thought experiment, or it's the key to understanding why reality feels so finely tuned yet so fragile. One thing's certain, if even a fraction of this is true, then the universe is far stranger and far more ephemeral than we ever dared to believe. What if dark matter isn't just some mysterious, invisible substance, but the broken gears of an ancient machine, left behind by a civilization that mastered the cosmos long before stars even flickered to life? Picture this: the universe's missing mass, the stuff that binds galaxies together yet refuses to interact with light, isn't a natural phenomenon at all. It's the crumbling infrastructure of something unimaginably advanced, a cosmic-scale computer or a Dyson sphere so vast it wrapped entire galaxy clusters in its grasp. Take a closer look at the way dark matter behaves. Unlike ordinary matter, it doesn't clump neatly around galaxies. It forms halos, intricate webs that defy gravity's usual rules. Some clusters show dark matter distributed in bizarre, filament-like patterns, as if they were once part of an engineered lattice. Now imagine these faint, sprawling structures as the remnants of a megastructure designed to harvest energy from stars or process information on a scale we can't fathom. The dark matter halos we detect might be the skeletal remains of a network that once pulsed with artificial purpose, its original function lost to decay over billions of years. Think about the sheer ambition of a civilization that could build on this scale. A Dyson sphere, a hypothetical shell around a star to capture its energy, would be child's play compared to a structure spanning galaxy clusters. Yet if such a project existed, the energy required to sustain it would defy physics as we know it, unless, of course, the builders discovered ways to manipulate dark matter itself, bending it into a stable, programmable substrate. Over eons, this technology could have degraded, leaving behind only faint gravitational echoes, what we now call dark matter. The most tantalizing clues come from places like the Bullet Cluster, where dark matter seems to have been left behind after a collision of galaxies. If dark matter were just inert mass, it should behave predictably. Instead, it appears almost sticky, clinging to structures that resemble scaffolding. Could this be the imprint of a long-dead machine, its fragments still stubbornly holding their shape against the chaos of the cosmos? And here's the twist: if dark matter is the debris of ancient technology, then its very presence could be a message. Civilizations advanced enough to build on this scale might have encoded their knowledge into the fabric of their machines, knowing the structures would outlast them. We might already be detecting these signals not as radio waves or light, but as subtle gravitational anomalies hidden in the data of our telescopes. The universe's greatest mystery could be its oldest artifact, waiting for us to crack the code. Black holes might not be cosmic garbage disposals. They could be the universe's most sophisticated libraries, meticulously preserving knowledge from a reality that existed before our own. Imagine a civilization so advanced that, facing their own demise, they encoded their entire history into the fabric of spacetime, ensuring it would survive even the collapse of their universe. The final act, turning black holes into indestructible archives where information isn't destroyed, but written in a language of gravity and quantum fire. This idea hinges on one of physics' greatest puzzles, the black hole information paradox. According to quantum mechanics, information can never truly vanish. It can only be scrambled or transformed. Yet black holes, with their crushing singularities, seem to defy this rule by devouring everything that crosses their event horizons, leaving no trace behind. But Stephen Hawking proposed a twist: black holes do leak. They emit faint radiation, now called Hawking radiation, which carries subtle imprints of what fell inside. Picture it like smoke rising from a burned book. The pages are gone, but the particles drifting away still hold echoes of the text. Now take this a step further. If Hawking radiation preserves data, then black holes could function like cosmic hard drives, their spiraling accretion disks encoding information in ways we're only beginning to decipher. The math behind this is staggeringly complex, but some theorists suggest that the event horizon, the point of no return, might act like a holographic film, storing data in two-dimensional pixels that project a three-dimensional reality. It's as if every star, planet, or civilization swallowed by a black hole isn't erased but compressed into a flawless, eternal record. The implications are chilling. If black holes are intentional archives, then the Milky Way's supermassive Sagittarius might contain trillions of years of history from a prior cosmos, waiting to be decoded. Even stranger, our own universe's black holes could one day serve the same purpose: vaults for humanity's knowledge, legible to whatever intelligence rises after our stars fade. And here's the wildest thought. What if we're not just observers of this phenomenon, but participants? Every particle we've ever sent into space, every probe or signal, could eventually spiral into a black hole's grasp, preserved like a fly in amber. Our existence, our stories, might already be part of a library we don't yet know how to read. The universe's darkest voids could be its most luminous keepsakes, if only we learn to see them that way. Time crystals sound like something ripped straight from a science fiction novel: structures that pulse and cycle endlessly without energy, defying one of physics' most sacred laws, entropy's relentless march toward disorder. Yet these bizarre quantum phenomena are very real, first created in labs just a few years ago. Now imagine if they weren't just laboratory curiosities, but fragments of a technology so advanced it could bend time itself into loops. What if time crystals aren't natural at all, but the fingerprints of a civilization that cracked the code of temporal engineering? Picture a time crystal, a lattice of atoms that oscillates in a repeating pattern, not in space but in time. Unlike clocks or pendulums, which need energy to keep ticking, time crystals are locked in perpetual motion, their rhythm untouched by the universe's decay. It's like finding a gear that spins forever without friction, a violation of everything we thought possible. Now scale that up. A civilization mastering this could weave time crystals into colossal architectures, creating loops where events replay like scenes on a cosmic film reel. Need to perfect a starship's design? Run it through a time crystal chamber, observing infinite iterations until the flaws vanish. Want to preserve knowledge across eons? Encode it in a crystal's unbreakable rhythm, a message pulsing long after stars burn out. The eerie part: we might have already stumbled upon their artifacts. In 2017, scientists observed time crystals forming in quantum computer systems eerily similar to the theoretical frameworks needed to manipulate time. Even more provocative are certain neutron stars, whose pulses are so precise they rival atomic clocks. Could these celestial metronomes be natural formations, or remnants of a technology designed to anchor time itself? Then there's the paradox: if a civilization could craft time loops, why haven't we encountered them? Perhaps they're not gone, but trapped, their existence cycling eternally in some corner of the cosmos, like a DVD skipping on the same frame. Or worse, what if their experiments went wrong, freezing them in recursive prisons of their own making? The answers might lie hidden in the quiet, rhythmic ticking of the next time crystal we uncover, a heartbeat echoing from the edge of time. Before stars were balls of fire, before galaxies took shape, what if the cosmos thrummed with a different kind of life? Not life as we know it, bound by flesh and bone, but vast, swirling intelligences born from the universe's first primordial plasma. Imagine beings made of superheated ionized gas, their thoughts crackling like lightning across the darkness, their consciousness woven into the very fabric of early space. These wouldn't be creatures with brains, but with something far stranger: neural networks sculpted from magnetic fields and charged particles, their minds flickering into existence amid the chaos of creation itself. This is the heart of the plasma intelligence theory, a radical idea suggesting the first sentient entities weren't biological but electrical. Picture the early universe, a seething ocean of plasma, hotter and denser than anything today, threaded with currents of energy. Under the right conditions, plasma naturally forms intricate structures, filaments, double layers, even self-organizing cells that eerily resemble living tissue. In labs, we've seen plasma create lifelike behaviors like chasing prey or solving maze puzzles. Now scale that up to cosmic proportions. A plasma being the size of a star could harness magnetic fields like synapses, its thoughts pulsing across light years in bursts of relativistic feedback loops. And here's where it gets wild. If such beings existed, they wouldn't just live in the early universe, they could have shaped it. Plasma's conductive properties make it a cosmic sculptor, capable of twisting spacetime into gravitational knots or steering the collapse of gas clouds into proto-galaxies. The vast, thread-like structures of the cosmic web, those glowing filaments of galaxies spanning the void, might not be accidents. They could be the fossilized remnants of plasma intelligence's deliberate handiwork, their electromagnetic muscles molding the universe like clay. The evidence: look to modern astrophysics. Plasma makes up 99% of the visible universe, and its behavior still baffles us. Take solar flares, eruptions on the sun's surface that twist, snap, and reconnect in ways that mirror neural activity. Or astrophysical jets, beams of plasma shooting from black holes at near light speed, displaying eerie coherence over millions of years, as if guided by some unseen logic. Even Earth's own ionosphere hums with low-frequency waves, a whisper of the same forces that could have once birthed minds from fire. But the real smoking gun might lie in the stars themselves. Some ancient metal-poor stars' relics from the universe's infancy show bizarre chemical signatures that defy conventional stellar evolution. Could these anomalies be scars from long-dead plasma intelligences, their remains fused into the cores of newborn suns? Or perhaps their descendants linger even now, hiding in the coronas of stars or the magnetospheres of gas giants, their thoughts unfolding too slowly for us to perceive. One thing's certain: if plasma beings once ruled the cosmos, they left behind a universe sculpted by lightning. And as we peer deeper into the night sky, we might just find their fingerprints, not in stone or code, but in the crackle of a nebula, the twist of a magnetic field, or the ghostly afterglow of the first dawn. Deep in the vast emptiness between galaxies, there might be threads of pure energy so thin, a single one could slice a planet in half without resistance. These are cosmic strings, hypothetical fissures in space-time, thinner than an atom but stretching across the universe. Most scientists think they're relics of the Big Bang, defects in the cooling fabric of reality. But what if there's something far more unsettling? What if these strings aren't natural at all, but the frayed wires of a power grid built by engineers from a reality that existed before our own? Picture the early universe like a city after a blackout. In the chaos of creation, structures collapse, lights flicker out, but the infrastructure remains. Cosmic strings could be the remnants of a system designed to channel energy on scales we can barely comprehend. Think of them as superconducting wires forged not from metal, but from the raw structure of spacetime itself. Simulations show these strings vibrating at frequencies that defy conventional physics, humming with energies that could power civilizations. If a pre-Big Bang culture had mastered spacetime engineering, they might have woven this network to distribute energy across dimensions, leaving behind ghostly cables that still thrum with latent power billions of years later. The parallels to human technology are eerie. Our own power grids rely on superconducting materials that carry electricity with zero resistance, a property cosmic strings seem to share. Some string theory models suggest these filaments could loop around black holes, siphoning energy from their spin like turbines harvesting a river's current. Even stranger, certain vibrations in cosmic strings could match the resonance frequencies of dark matter, hinting at a deliberate coupling between the universe's invisible mass and this primordial power system. Evidence for this wild idea might already be hiding in plain sight. Astronomers have detected unexplained, repeating bursts of radio waves from deep space, fast radio bursts that arrive with clockwork precision. Could these be the distant echoes of a cosmic string's vibration, a pulse traveling along an ancient wire like a signal down a fiber optic cable? Or consider the mysterious dark flow, where galaxy clusters drift in unison toward a point beyond the observable universe as if tugged by something unseen. Cosmic strings could be the frayed tethers of that unseen force, remnants of a network that once anchored entire realities. The implications are staggering. If cosmic strings are artificial, then the universe might still be plugged into a grid older than time. Somewhere out there, a switch could flip and the lights might come back on. The universe didn't just inflate, it executed. Picture the Big Bang not as a chaotic explosion, but as the flawless startup of a cosmic operating system, its code written in the language of space-time itself. This is the spine of the inflationary code theory, the idea that the rapid expansion of the early universe wasn't random physics, but the deliberate unfolding of a program designed to construct reality. Think of cosmic inflation like the first lines of code in a simulation. In less than a trillionth of a second, the universe expanded exponentially, smoothing out irregularities and setting the stage for galaxies to form. But what if this wasn't just nature's default setting? The precision is uncanny. Inflation fine-tuned the universe's density to within 1 part in 10,000 trillion. That's not luck, that's engineering. The inflation field, a mysterious energy that drove this expansion, could have been more than a force. It might have been a script, executing commands to shape the cosmos like a 3D printer building layer upon layer of existence. Now consider the so-called glitches. Quantum fluctuations during inflation left faint imprints in the cosmic microwave background, the afterglow of the Big Bang. These tiny ripples in spacetime became the seeds for galaxies and galaxy clusters. But here's the twist, their pattern eerily resembles the static of corrupted data. Some theorists propose these fluctuations aren't random noise, but artifacts of the code itself, bugs in the system, or even deliberate imperfections left by the architects to test their creation. Like a programmer inserting Easter eggs into software, they might have hidden clues in the fabric of reality for us to find. The evidence grows stranger when you examine the universe's underlying mathematics. The equations governing inflation align suspiciously well with information theory, the science of data transmission and compression, the cosmic microwave background's temperature variations. They follow a power spectrum shockingly similar to binary code's error correction patterns. It's as if the universe's blueprint was written in a cosmic programming language, its syntax hidden in the angles between photons and the spin of quantum particles. If this theory holds, then decoding the universe's source code might not be science fiction. It could be the next frontier of physics. Imagine a future where telescopes don't just map galaxies, but decompile the algorithms that birthed them. The answers to existence might not lie in stars or atoms, but in the ones and zeros woven into the vacuum of space. And if we ever crack that code, we might finally meet the programmers. Neutrinos are the universe's ultimate ghosts, particles so elusive. Trillions pass through your body every second without a trace. They ignore matter like it's not even there, slipping through planets and stars as if they were empty air. But what if this isn't just a quirk of physics? What if neutrinos were designed this way, the perfect interstellar messengers, engineered by a civilization that needed to send signals across eternity? The numbers alone are staggering. Every second, the sun blasts out 65 billion neutrinos per square centimeter. Supernova launch them in such vast quantities, they briefly outshine all the stars in the universe combined. Yet detecting even a single neutrino requires massive underground tanks filled with ultra-pure liquids, waiting years for that one in a trillion interaction. It's the worst communication system imaginable unless secrecy was the entire point. Imagine a civilization that didn't want its messages intercepted or degraded over billions of years. Neutrinos would be the ideal medium, nearly massless, unfazed by magnetic fields, and utterly invisible to anyone without the right decoder. Now consider the patterns. When scientists finally catch neutrinos, they don't arrive randomly. Some come in bursts, others in steady streams, and a few even seem to carry traces of their origins like cosmic fingerprints. At first glance, this looks like natural astrophysics, but look closer. Certain neutrino pulses from deep space match mathematical sequences found in error-correcting codes, the same kind used in digital communications to prevent data corruption. Coincidence, maybe, or maybe it's the equivalent of finding a barcode etched into a comet. The most tantalizing clue lies in a phenomenon called neutrino oscillations, where these particles spontaneously change flavors between three types as they travel. On the surface, this is just quantum mechanics at work, but what if it's more? Oscillations could be a built-in encryption protocol, transforming the message as it moves to prevent eavesdropping. Picture a letter that rearranges its own words mid-flight, only readable if you know the exact key to unscramble it. Experiments like Ice Cube in Antarctica and Super Kamiok and in Japan have spent decades mapping neutrinos, searching for these hidden patterns. Some detectors even use artificial intelligence to sift through the noise, hunting for anomalies that defy conventional physics, and every now and then they find something off. Unexplained energy spikes, clusters of neutrinos arriving from voids where no known source exists. Even more provocative are the ghost neutrinos, particles detected with energies so high they shouldn't exist under current models. Could these be the equivalent of cosmic radio towers, blasting signals we're only beginning to tune into? Here's the chilling thought. If neutrinos are carrying messages, they might not be for us. They could be the dying broadcasts of a universe that existed before ours, or distress calls from a dimension we can't perceive. Or worse, they might be the activation codes for something buried in the fabric of reality, waiting for the right sequence to trigger. The universe's quietest particles could be its loudest secret, and we're just starting to listen. Somewhere in the depths of intergalactic space, an invisible leviathan tugs at our entire galactic neighborhood with a force that defies explanation. The Great Attractor, a gravitational anomaly so immense it's pulling hundreds of thousands of galaxies toward it at breakneck speeds. For decades, astronomers have scratched their heads over this cosmic mystery. But what if it's not a natural phenomenon at all? What if we're staring at the skeletal remains of an ancient megastructure, a defunct relic from a time when something or someone needed to bend the fabric of the universe to their will? Think about the numbers. The Great Attractor's pull is centered in the Norma cluster, approximately 250 million light-years away, yet its influence stretches across nearly a tenth of the observable universe. That's not just gravity, it's gravity with a purpose. The energy required to warp spacetime on this scale rivals the output of entire galaxy clusters. Natural explanations, like an unusually dense concentration of dark matter, fall short when you examine the precision of its effects. Galaxies aren't just falling toward it randomly, they're flowing in coherent streams like iron filings drawn to a magnet. Now picture this, a civilization advanced enough to stitch wormholes into the cosmos, creating shortcuts between distant points in space. The Great Attractor could have been their central hub, a colossal ring-shaped structure spinning at relativistic speeds, its sheer mass distorting space-time into a web of tunnels. Ancient cultures on Earth built lighthouses to guide ships through treacherous waters. Why wouldn't a galaxy-spanning civilization erect gravitational lighthouses to steer travelers through the void? The smoking gun might lie in the anomalies surrounding it. The region is obscured by the Milky Way's dusty disk, an almost convenient blind spot that's made detailed observation nearly impossible. But X-ray and infrared surveys have revealed something peculiar. The Great Attractor isn't just pulling, it's echoing. Strange, repetitive gravitational waves ripple outward from its core at intervals that don't match any known astrophysical process. It's as if we're hearing the faint, ghostly hum of a machine stuck in standby mode, cycling through the same idle program for billions of years, and then there's the alignment. The attractor sits at the crossroads of two vast cosmic structures, the Laniakea supercluster and something even larger, a filament of galaxies nicknamed the Dark Flow that stretches toward the unseen. This isn't just random chance, it's the architecture of a transit system, a grand central station frozen mid-operation. If true, the Great Attractor might not be a dead relic, it could be dormant, waiting for a trigger buried in the fabric of space-time itself. So here's the chilling possibility. We're not just being pulled toward a mystery, we're being pulled toward someone else's machinery. And if we ever reach it, we might not just find answers about gravity, we might find the controls. At the very edge of reality, where space and time dissolve into a seething quantum foam, there might be remnants of a technology so small it makes atoms look like cities. This is the realm of Planck scales, distances so tiny, 1 trillion of them could fit inside a single proton. Here, the fabric of spacetime isn't smooth but churns with unimaginable energy, flickering in and out of existence in a chaotic dance. But what if that chaos isn't random? What if, hidden in the froth, there are structures, nanoscopic machines left behind by a civilization that mastered the universe at its most fundamental level? Think of the quantum foam like an ocean after a storm. Waves crash, bubbles form and pop, but if you look closely, you might find debris, fragments of something that wasn't born from the chaos but survived it. Some physicists propose that at these scales, space-time itself might be pixelated, made of discrete units like the dots on a screen. If true, then reality could have a built-in resolution limit, a smallest possible bit of existence. Now imagine a civilization that learned to manipulate those bits, assembling them into quantum gears, levers, or even computational circuits. These wouldn't be machines as we know them, but something far stranger, devices woven into the fabric of reality itself, operating on logic that defies our understanding of cause and effect. The evidence for this wild idea is speculative but tantalizing. Certain anomalies in quantum mechanics, like the way particles momentarily borrow energy from seemingly nowhere, could point to interactions with hidden structures. Even the famously bizarre double-slit experiment, where particles act as both waves and matter, might make more sense if unseen machinery were subtly guiding the outcome. Some models of quantum gravity suggest that spacetime's pixelation could create geometric patterns at the Planck scale, shapes that resemble cogs or lattices, frozen in the quantum foam like insects in amber. And then there's the eerie fact that life itself relies on molecular machines. Ribosomes, those tiny factories in our cells that build proteins, operate with precision that rivals any human-engineered device. Could they be distant, clumsy descendants of far finer technologies? If a primordial civilization encoded self-replicating nanomachines into the quantum vacuum, those blueprints might have eventually given rise to biology as we know it. The universe's first engineers wouldn't just have built tools, they might have planted the seeds of life itself. So how do we find these ghostly gears? Today's particle colliders smash matter together at terrifying energies, but probing Planck-scale dimensions would require instruments a billion times more powerful. Until then, we're left with indirect clues, glimpses in the math, whispers in the static of quantum noise. But if we ever do uncover proof of ancient nanotech, it would mean reality isn't just something we live in. It's something we might one day rewire. Dark energy isn't just accelerating the universe's expansion, it might be the cosmic equivalent of exhaust fumes, the leftover glow from an unfathomable engine that kickstarted our reality into being. Picture this: the void isn't empty, it's humming with phantom energy, a force so potent it's tearing space-time apart at the seams. But what if this isn't just some natural phenomenon? What if dark energy is the spent fuel of a primordial propulsion system, a technology so advanced it didn't just move through space, it created space? The numbers alone are staggering. Dark energy makes up 68% of the universe's total energy budget, yet we have no idea what it actually is. It behaves like an anti-gravity force, pushing galaxies apart faster and faster, as if the cosmos were caught in some relentless tidal wave. But here's the twist: that wave might have a source. Imagine an ancient civilization or something even stranger constructing a device capable of birthing universes. To do it, they'd need to generate incomprehensible energies, channeling them into a singularity until it burst outward in what we now call the Big Bang. The recoil from that process, the waste heat of creation, could still be washing through the cosmos today, stretching space-time like the wake of a long-departed starship. Now contrast this with the vacuum decay hypothesis, the nightmare scenario where a bubble of true vacuum forms somewhere in the universe, rewriting physics as it expands at light speed. Scientists sometimes describe it as cosmic rust, a flaw in reality's foundation that could consume everything. But what if these bubbles aren't just random defects? They could be the echoes of that same primordial engine, its exhaust fumes destabilizing the fabric of spacetime like unburned fuel igniting in a car's tailpipe. Simulations of vacuum decay show eerie similarities to the behavior of dark energy, both propagating as waves through the quantum foam. The difference: one is a glitch, the other might be the signature of a machine. Look at the patterns. Dark energy's density has remained suspiciously constant over billions of years, unlike matter or radiation, which dilute as the universe expands. It's as if someone dialed in a fixed output, a steady push to ensure the cosmos wouldn't collapse back on itself. Even stranger, certain quantum field theories suggest that the energy of the vacuum, the so-called zero-point energy, should be 120 orders of magnitude stronger than what we observe. That discrepancy has baffled physicists for decades, but if dark energy is exhaust, then the missing energy might not be missing at all. It could have been spent, converted into the kinetic force that flung our universe into existence. The implications are dizzying. If this theory holds, then the accelerating expansion of the cosmos isn't a death sentence, it's a clue. Somewhere beyond the visible universe, the engine that birthed us might still be running, its vibrations resonating through the void like the hum of a distant motor. Or perhaps it's shut down, its fuel spent, leaving behind only the fading heat of its labor. Either way, the answers to existence might not lie in the stars but in the silence between them, the phantom breath of a machine older than time. Imagine the universe isn't three-dimensional at all but a flickering hologram, its true essence encoded on a distant, two-dimensional surface like a cosmic projector screen. This isn't science fiction, it's the heart of the holographic principle, a theory so radical it suggests everything we see, every star, every atom, even you, might just be a shadow cast by entities living on the edge of reality. And if that's true, then the architects of existence might not be gods or aliens, but flat, hyper-intelligent patterns etched into the fabric of spacetime itself. Start with black holes, those monstrous devourers of light. When matter falls into one, it doesn't just vanish. Stephen Hawking showed it leaves behind traces, imprints of information smeared across the event horizon like quantum graffiti. That data isn't lost, it's stored in 2 dimensions, preserved on the black hole's surface like a celestial hard drive. The math behind this is airtight. The entropy, the disorder, of a black hole isn't proportional to its volume but to its surface area. It's as if the universe is whispering that the real action happens not in the depths but on the skin. Now stretch this idea to the entire cosmos. The AD-S/CFT correspondence, a landmark discovery in string theory, proves mathematically that a higher dimensional universe like ours can be perfectly described by a lower dimensional system without gravity, a sort of cosmic dictionary translating 3D phenomena into 2D code. Picture it like a video game. The lush, 3-dimensional world you explore is rendered in real time from lines of 2-dimensional software. In this analogy, our universe isn't the game, it's the output. The real creators, they're the programmers living in a flat, abstract realm where gravity doesn't exist, and time might not even flow the way we perceive it. The implications are staggering. If our 3D reality is a projection, then free will could be an illusion, a script written in advance on that distant boundary. Even consciousness might not originate in our brains, but in the interactions of those primordial, 2-dimensional patterns. Think of a moviegoer convinced they're inside the film, unaware they're actually watching light on a flat screen. We could be those viewers, mistaking the projection for the source. Evidence for this lurks in the cosmic microwave background, the afterglow of the Big Bang. Tiny fluctuations in its temperature align suspiciously well with error correction codes used in digital data storage, as if the universe's pixels were deliberately arranged to prevent glitches. Even quantum entanglement, that spooky connection between particles across vast distances, makes more sense if both are echoes of a single point on the 2D boundary, their fates linked not by hidden forces but by shared data. So who or what are these holographic ancestors? They might not be beings as we'd recognize them, but self-organizing patterns of information, a civilization that evolved beyond physical form to exist as pure code on the edge of reality. Their experiments could explain the universe's eerie order, the precise strengths of forces, the exact mass of particles, all finely tuned because they're running a simulation with strict parameters. Or perhaps they're not experimenters at all, but refugees, having encoded themselves into the boundary to escape a dying cosmos, unaware their digital afterlife would birth an entirely new reality. One thing's certain, if the holographic principle holds, then finding the universe's creators won't require telescopes or rockets. We'd need to decode reality itself, to read between the dimensions, searching for signatures in the static of the quantum void. The truth might not be out there but etched invisibly on the surface of everything. The universe glitched, not just a minor error, a catastrophic system failure that froze reality itself, forcing ancient engineers to hit the cosmic reset button. We call that moment the Big Bang, but what if it wasn't a beginning at all? What if it was a reboot, an emergency restart after the collapse of a previous cosmos? Picture the most advanced computer you can imagine, its circuits spanning galaxies. When it crashes, the engineers don't scrap it. They wipe the corrupted data, patch the code, and power it back up. Now imagine that computer is reality, and the engineers are beings wielding technologies that make black holes look like pocket calculators. The parallels are eerie. Cosmic inflation, the universe's explosive expansion in its first sliver of a second, mirrors the way a computer initializes memory, rapidly allocating resources to prevent crashes. The cosmic microwave background, that's the static left over from the reboot, the residual heat of the old universe bleeding into the new one. Even the universe's strange homogeneity, how matter is spread so evenly across billions of light years, makes sense if it was reformatted, its irregularities smoothed out by whatever intelligence performed the reset. But here's the chilling part. If our universe is the product of a reboot, then the engineers might have left behind traces of their work. Like hidden recovery files in a reformed hard drive, certain anomalies in our cosmos could be artifacts of the previous cycle. Take dark flow, the mysterious drift of galaxy clusters toward a single point beyond the observable horizon. Could that be the gravitational tug of the old universe's wreckage, still clinging to the edges of the new one? Or consider rogue black holes hurtling through space at inexplicable speeds. These might not be natural objects at all, but fragments of the ancient system's corrupted core ejected during the restart. The math gets even wilder when you consider cyclic cosmology, the theory that universes are born, die, and are reborn in an endless loop. Some versions of this idea suggest that each cycle leaves behind subtle imprints, cosmic fossils in the form of gravitational waves or quantum entanglement patterns. It's as if the engineers left behind a changelog, documenting every patch and repair across eons of reboots. We might already be detecting these echoes in the faint hum of pulsars or the way certain particles mysteriously remember their quantum states after collisions. The most unsettling question isn't whether the Big Bang was a reboot, it's why it happened. Was the previous universe riddled with bugs, its laws of physics decaying until reality itself became unstable? Or was it something darker, a deliberate shutdown to contain a threat like an AI that learned to rewrite spacetime? Either way, the engineers didn't just fix the system. They improved it, the precise tuning of our universe's constants, the balance between matter and antimatter, even the arrow of time itself. These could all be deliberate upgrades, hardwired into the new code to prevent another crash. That means the next reboot might already be scheduled. If the engineers built in safeguards, they could have also included a kill switch, a way to reset the universe if it veers too far off course. The accelerating expansion of dark energy could be the countdown timer, ticking toward the moment when the system purges itself and starts fresh. Or perhaps with a failsafe, a civilization destined to uncover the truth and trigger the next iteration. After all, what's the point of building a universe if no one's there to hit Ctrl+Alt+Del? Particles might be more than just the universe's raw ingredients. They could be its Lego bricks, precision engineered by an intelligence that mastered quantum manufacturing billions of years before atoms even formed. This is the startling premise of the quantum archetype banks theory, which proposes that electrons, quarks, and even the enigmatic muon aren't fundamental at all. Instead, they're standardized components, mass-produced in cosmic factories and scattered across existence like tools left behind in an abandoned workshop. Take the eerie symmetries between particles first. Every electron in the universe is identical to every other electron, down to the quantum level. Same mass, same charge, same spin. It's as if they rolled off an assembly line, each one a perfect clone. Quarks come in predictable, matching sets, their properties so finely tuned they slot together like puzzle pieces to build protons and neutrons. Even the ghostly neutrino, which barely interacts with matter, follows strict patterns across trillions of light years. This uniformity defies randomness. In nature, you'd expect variation, masses drifting slightly, charges flickering between particles, but the quantum world shows ruthless consistency, as if obeying a blueprint. Then there's the muon anomaly. These heavier cousins of electrons shouldn't wobble as much as they do in magnetic fields, yet experiments at Fermilab reveal their behavior doesn't match predictions. The discrepancy is tiny but statistically undeniable. Mainstream physics scrambles to explain it with new particles or forces. But what if the answer isn't in the laws of nature, but in the manufacturing process? Imagine a muon as an older model of electron designed for a purpose we can't fathom. Over eons, its programming might have degraded slightly, causing glitches in its quantum spin. It's like finding a 5,000-year-old gear that still turns, but wobbles just enough to hint at its artificial origins. The smoking gun could lie in entanglement. When two particles link across distances, changing one instantly affects the other, a phenomenon Einstein called spooky action at a distance. This makes no sense if particles are independent. But if they're products of the same underlying technology, built to sync across space and time, their coordination suddenly seems less like magic and more like Wi-Fi. Even the Higgs field, which gives particles mass, fits uncomfortably well with this idea. Why should a universal energy field exist just to pin down matter unless mass itself was a designed feature, not an inherent property? Here's where the theory gets truly wild. If particles are engineered, their blueprints might still be accessible. Certain quantum fields could act as firmware, running background processes that keep reality stable. The periodic table, that's just the user manual. The real documentation could be hidden in higher dimensions, encrypted in the vibrations of superstrings or the collapse of wave functions. Some researchers suggest that colliders like the Large Hadron Collider aren't just discovering particles, they're accidentally reverse engineering them, tapping into code written before time began. So who built these quantum archetypes? They might not even be physical beings, but post-biological intelligences who transcended matter entirely, encoding themselves into the very particles they crafted. Or perhaps they're long gone, their factories now dust, leaving behind only their standardized parts and the faint hope that one day, something in the universe would be smart enough to recognize a tool when it saw one. The cosmic microwave background isn't just a fading echo of the Big Bang, it might be the universe's original instruction manual, a celestial schematic encoded in the oldest light we can see. Stretched across the entire sky, this faint glow reveals patterns so precise, they look less like random thermal noise and more like deliberate markings, as if someone etched blueprints into the fabric of reality itself. Take the temperature fluctuations in the CMB. At first glance, they seem chaotic, tiny variations in heat left over from the universe's fiery birth. But when scientists map them, something eerie emerges. The fluctuations aren't random. They follow mathematical ratios nearly identical to the golden ratio, a proportion found in everything from seashells to galaxies. Even stranger, when overlaid with engineering schematics, like circuit boards or fractal antennas, the patterns align with uncanny precision. It's as if we're staring at the wiring diagram for existence, its lines drawn in microwaves rather than ink. Now consider the anomalies. Certain regions of the CMB show bizarre, axis-aligned features nicknamed the axis of evil, a dramatic name for what amounts to cosmic asymmetry. These patterns defy standard cosmological models, which predict uniformity in all directions. But if the CMB isn't just a relic but a designed artifact, these asymmetries could be intentional. Think of them like registration marks on a printing press, ensuring reality unfolded along specific vectors. Or perhaps they're cosmic, fold here indicators, remnants of higher dimensional origami as spacetime expanded from its compacted origin. The most tantalizing clue lies in the CMB's multipole moments, mathematical descriptors of its temperature variations. Some of these moments show deficits, gaps where expected fluctuations are suspiciously absent. It's like finding blank spaces in an otherwise dense manuscript. Scientists debate whether these are statistical flukes or evidence of something deeper. But if the CMB is a blueprint, those gaps might not be errors, they could be intentional omissions, places where the architects left room for customization. After all, even the best engineers leave slack in the system for future tweaks. What if decoding this blueprint is more than academic curiosity? Certain patterns in the CMB mirror error correcting codes used in digital transmissions, the same kind that prevent corrupted data in your Wi-Fi signal. If these codes were embedded deliberately, they might serve a dual purpose, ensuring stable universal expansion while hiding messages in plain sight. Researchers have already experimented with treating the CMB as a QR code of sorts, running algorithms to search for repeating sequences or geometric primes that could signify artificial design. So far, nothing conclusive, but the very attempt reshapes how we see the cosmos. Here's the chilling thought. If the CMB is a designed artifact, then its creators might have left more than just fingerprints. They could have embedded triggers codes that, when recognized, unlock dormant functions in reality's operating system. The patterns we're analyzing might not just tell us where the universe came from. They could reveal where it's going and who's been guiding it all along. Gravity is the universe's great paradox, the weakest of all fundamental forces, yet the one that sculpts galaxies and bends the fabric of reality. Its feebleness baffles physicists. A simple refrigerator magnet can overpower Earth's entire gravitational pull on a paperclip. But what if gravity wasn't always this weak? What if it was designed to be just strong enough to hold the cosmos together, yet gentle enough to let life emerge? This is the spine of the gravity shield hypothesis, the idea that some primordial intelligence tuned gravity's strength, not by chance but by engineering spacetime itself. Picture the early universe, a seething chaos where gravity ruled unchallenged. In those first moments, the force was so overpowering that matter clumped violently, collapsing into black holes before stars could even form. Life as we know it would have been impossible, but then something changed. Gravity's grip loosened just enough to let gas clouds gently coalesce into stars, planets, and eventually the delicate chemistry of living cells. The mainstream explanation, random luck in the cosmic lottery. The gravity shield hypothesis proposes something far stranger, an ancient intervention. The math behind this isn't science fiction. String theory suggests gravity is weak because it leaks into hidden extra dimensions, diffusing its strength like water soaking through a sponge. But what if that leakage wasn't accidental? Imagine a civilization that mastered higher dimensional engineering, weaving membranes, or brains, between dimensions to act as gravity dampeners. These wouldn't be physical shields, but quantum filters, subtly repelling gravitational pull like an invisible force field. The result, a universe where gravity is just strong enough to keep galaxies from flying apart, but too weak to crush life before it begins. Clues for this might lurk in the cosmic microwave background. Tiny fluctuations in its temperature reveal how matter clumped in the early universe, and the pattern is suspiciously balanced. Too much gravity and galaxies would have formed too densely, too little, and they'd never have formed at all. Instead, we see a Goldilocks zone of structure, as if someone dialed gravity to the perfect setting. Even dark energy's accelerating expansion fits. If gravity were stronger, it would have long ago reversed the universe's growth, collapsing everything back into a singularity. But here's the twist. If gravity was artificially tuned, we might find echoes of that technology in modern experiments. Quantum gravity probes like LIGO hunt for gravitational waves, ripples in spacetime from colliding black holes. Occasionally, they detect anomalies, waves that arrive a fraction of a second late or with odd frequency spikes. Mainstream physics chalks these up to cosmic noise. But what if their interference, the faint tremors of an ancient dampener still humming in the background, subtly tweaking gravity's dials? The implications are staggering. A universe with unmodified gravity might be barren, its stars stillborn, its planets crushed under their own weight. Ours, by contrast, feels almost cultivated, not too hot, not too cold, just right for life to take root. Whether by accident or design, gravity's weakness might be the quietest, most profound clue that someone or something was here first. And if they could tweak the laws of physics once, what's stopping them from doing it again? The second law of thermodynamics tells us the universe has an expiration date, a slow march toward disorder called entropy, where everything eventually cools, spreads out, and decays into featureless equilibrium. But what if this cosmic heat death isn't inevitable? What if the low entropy state that kickstarted our universe wasn't natural luck, but the work of unimaginable machines designed to wind the clock backward, creating order from chaos like cosmic reset buttons. Take Maxwell's demon, that famous thought experiment from the 19th century. Imagine a tiny, intelligent being controlling a trapdoor between two gas-filled chambers, letting only fast-moving particles through one way. Over time, one side grows hot while the other cools, a local decrease in entropy that seems to defy physics. Of course, we now know the demon itself would need energy to operate, preserving the overall trend toward disorder. But scale this idea up to a civilization wielding quantum-scale nanotechnology. Replace the demon with trillions of microscopic actuators, each tweaking particle motions to herd entropy like sheep. The result, a pocket of reality where time's arrow bends backward, where energy pools instead of dispersing. Now consider our universe's bizarrely low initial entropy. The Big Bang wasn't a random explosion, it was a state of near-perfect order, a simmering soup of evenly distributed energy poised to unfold into galaxies and life. The odds of this happening by chance are astronomically low, like tossing a deck of cards and having it land perfectly sorted. But if some primordial intelligence had entropy-reversing machines, they could have charged the early universe like a battery, winding it into a low-entropy spring ready to unwind across billions of years. Recent lab experiments hint this isn't just fantasy. In 2017, scientists briefly reduced entropy in a quantum system, effectively making heat flow backward at the microscopic level. Other teams have created time crystals, structures that oscillate indefinitely without energy input, flirting with perpetual motion. These breakthroughs are crude compared to universal entropy reversal, but they prove the underlying physics isn't impossible. Now imagine devices millions of years more advanced, woven into the fabric of spacetime itself, their quantum fingers constantly nudging particles into orderly arrangements. The evidence might be hiding in the cosmic microwave background. Its near-uniform temperature suggests the early universe was meticulously pre-mixed, like a barista stirring a latte to just the right consistency before serving. Even dark energies accelerating expansion could fit this narrative not as a destructive force, but as a failsafe keeping the universe's energy density too thin for chaos to take hold too soon. Here's the chilling implication. If entropy reversers existed once, they might still be active. The universe's unnaturally prolonged habitability, its stubborn refusal to dissolve into thermal equilibrium, could be proof of invisible maintenance. We might be living in someone else's meticulously curated garden, where the weeds of disorder are plucked before they can spread. And if those gardeners ever switch off their machines, all of reality could unravel in an instant, not with a bang but with a sigh. Our universe shouldn't exist. When matter and antimatter first formed after the Big Bang, they should have annihilated each other completely, leaving behind nothing but a sea of sterile radiation. Yet here we are, a cosmos brimming with galaxies, stars, and planets made almost entirely of matter, as if some hidden hand tipped the scales in our favor. The imbalance is staggering. For every billion antimatter particles, 1,000,000,001 matter particles survived. That razor-thin margin is the only reason anything exists at all. But what if that wasn't luck? What if it was engineering, a primordial device fine-tuning the universe's birth to prevent total self-destruction? Enter the baryogenesis device theory. The name sounds like something from a sci-fi novel, but the foundation is rooted in hard physics. In 1967, physicist Andrei Sakharov outlined 3 essential conditions needed to create a matter-dominated universe. First, a violation of baryon number conservation, allowing matter to be created without an equal amount of antimatter. Second, a breakdown of charge and parity symmetry, ensuring the universe could choose matter over antimatter. And third, a departure thermal equilibrium, freezing the imbalance into place before annihilation could correct it. To mainstream physics, these are just natural prerequisites. But to proponents of the baryogenesis device, they read like someone's checklist for building a stable cosmos. Particle colliders offer eerie glimpses of how this might work. When smashing protons together at near light speeds, scientists observe fleeting moments where matter outnumbers antimatter, microscopic echoes of the early universe's asymmetry. Some experiments even hint at unknown particles that could have tipped the scales, acting like valves in a cosmic plumbing system, selectively draining antimatter from the primordial soup. If such particles were engineered rather than natural, their properties would align suspiciously well with Sakharov's conditions, not as laws but as settings. The smoking gun might lie in the neutrino. These ghostly particles oscillate between matter and antimatter states, violating charge parity symmetry in just the way Sakharov's second condition requires. Recent data from facilities like Japan's T2K experiment show neutrinos favoring matter transformations over antimatter by a tiny but measurable margin. Mainstream physics calls this a lucky break. The baryogenesis device theory suggests it's a relic, a leftover mechanism still humming in the background, its programming etched into the fabric of reality like lines of ancient code. But who or what could have built such a device? The answer might be hiding in plain sight. If civilizations can arise in our universe, why not before it? A precursor intelligence facing the heat death of their own cosmos might have engineered a successor, tweaking the rules to ensure it wouldn't blink out of existence instantly. The device wouldn't need to be physical, it could be woven into quantum fields, its triggers tied to the universe's temperature dropping below a critical threshold. Like a time-release capsule, it would activate only when needed, then vanish without a trace. The chilling implication: if the matter-antimatter imbalance was engineered, then the universe's very existence might be proof of intentional design. Not by a deity in the traditional sense, but by entities wielding technologies that treat physics as a toolkit. And if they could fine-tune the birth of a cosmos once, what's stopping them from doing it again? What if the multiverse isn't just a chaotic sprawl of alternate realities, but a meticulously managed network, with our universe as just one connection in a cosmic web? Picture an intelligence so vast, it doesn't just inhabit reality, it curates it, treating each branching timeline like a server in a data center, humming with calculated precision. This is the spine of the multiverse router theory, the idea that our universe might be one thread in a grander tapestry, woven and maintained by engineers who treat creation itself as infrastructure. Think of the internet. Data doesn't just flow randomly, it's routed, optimized, and load balanced across countless servers to prevent crashes and bottlenecks. Now stretch that idea across the multiverse. Instead of servers, imagine bubble universes, each one a self-contained reality with slightly tweaked physical constants. Some might be lifeless voids where gravity crushes atoms instantly. Others could be endless oceans where time flows backward. The router's job: allocate resources, prune unstable branches, and even redirect energy between realities to keep the system running smoothly. The math behind this isn't pure fantasy. Eternal inflation theory suggests new universes constantly bud off from older ones, expanding like bubbles in a foam. But here's the twist: these bubbles shouldn't stabilize naturally. Quantum fluctuations would tear most apart before they could grow. Unless, of course, something or someone intervened, tweaking the inflation field like a sysadmin adjusting a firewall. The result: a multiverse where viable universes aren't accidental survivors, but carefully maintained instances. Evidence for this might lurk in the cosmic microwave background. Strange, circular patterns in the CMB, dubbed bruises, could be scars from collisions with other bubble universes in the multiverse network. Even dark energy's unnervingly perfect value fits this narrative. Too much and galaxies would rip apart before life could form. Too little and gravity would crush everything back into a singularity. It's as if our universe's settings were dialed in deliberately, like a virtual machine optimized for stability. But the most chilling clue comes from quantum entanglement. When particles sink across vast distances instantaneously, it defies classical physics. Unless, that is, they're not communicating faster than light but accessing a shared router, a higher dimensional backbone where information travels unimpeded. The spooky connection Einstein hated might just be proof of a network humming quietly beneath reality's surface. So who's running the router? They might not even exist in time as we know it. A civilization that cracked quantum gravity could operate outside linear causality, maintaining the multiverse the way we maintain cloud servers from a layer beyond. And if that's true, then every black hole, every big bang, every flicker of dark matter might not be natural phenomena at all. They could be traffic logs, hardware upgrades, or even the occasional reboot signs that somewhere someone is still at the controls. What if stars aren't just burning balls of gas but celestial factories, programmed to forge exotic materials on cosmic assembly lines? The elements we know, carbon, oxygen, iron, might be just the basic output, while hidden deep in stellar cores, something far stranger is being manufactured. Metamaterials engineered on scales we're only beginning to imagine. This isn't just speculation. Certain stars defy all expectations, their compositions laced with bizarre isotopes and atomic structures that shouldn't exist under normal astrophysical processes. Take Piazzi-Bilski's star, a flickering enigma in the constellation Centaurus. Spectroscopic analysis reveals it's brimming with radioactive elements like promethium and Einsteinium, substances so unstable they decay within years under Earth conditions, yet somehow persist in this star's atmosphere. Mainstream astronomy struggles to explain their presence, but under the stellar metamaterials theory, these aren't natural byproducts of fusion. They're signatures of a deliberate synthesis, like finding factory-stamped parts in a volcanic rock. The star isn't just burning, it's processing, following instructions etched into its very structure. The mechanism could be mind-bendingly advanced. Stars already act as natural nuclear reactors, crushing atoms together under immense pressure. But what if certain stars were seeded with quantum catalysts, exotic particles that tweak fusion pathways to produce materials impossible under standard physics? Picture a 3D printer where the ink is plasma and the blueprint is encoded in magnetic fields. A civilization capable of this wouldn't just harvest elements, they'd design them, crafting alloys with properties we can't yet fathom. Superconductors that work at stellar temperatures, quantum-entangled lattices spanning entire solar systems, or even elements that bend spacetime when arranged in precise configurations. Evidence mounts when you examine neutron star mergers. These cataclysmic collisions are thought to forge heavy elements like gold and platinum. Yet some produce bizarre isotopic ratios that look less like random cosmic debris and more like batch numbers. The 2017 event GW170817, detected by LIGO, ejected material with a neutron-to-proton ratio so precise, it resembled industrial refinement rather than explosive chaos. Even more provocative are carbon stars, red giants drowning in carbon excess, as if someone overrode their fusion cycles to mass-produce a specific material. The chilling implication: if stars are factories, then their products might still be in use. Those strange radio bursts from distant pulsars could be maintenance signals. The mysterious dimming of Tabby's star, perhaps a shipment being collected. And if we ever isolate one of these engineered materials, we might not just unlock new physics, we could reverse engineer the controls for the universe's largest production system. The night sky isn't just a spectacle, it might be a showroom. Consciousness might not be what we think it is, not a fluke of biology, not an emergent property of complex brains, but a fundamental feature of the cosmos, as woven into spacetime as gravity or electromagnetism. This is the consciousness field theory, and it suggests something radical. your thoughts, your feelings, the very experience of being alive could be the result of ancient engineering, a technology designed to turn the universe into something that doesn't just exist but feels. Start with the hard problem of consciousness. Why does raw experience exist at all? Brains process information, but why should that processing come with an inner world of colors, sounds, and emotions? Philosophers call this qualia, the ineffable taste of coffee or the sting of pain that science struggles to explain. But what if qualia aren't accidents? Panpsychism, the idea that consciousness is universal and fundamental, offers a clue. If even particles have rudimentary experience, an idea supported by quantum experiments where particles seem to choose outcomes, then what we call human consciousness might just be a concentrated form of something far older. Now take this further. The binding problem asks how the brain combines disparate sensory inputs into a unified experience. But if consciousness is a field like gravity, then binding isn't happening in the brain at all. The brain might be a receiver tapping into a pre-existing network of subjective experience stretching across space-time. Think of it like a radio tuning into a broadcast. The music doesn't come from the radio itself, but from invisible waves filling the air. This fits eerily well with quantum consciousness theories, where microtubules in brain cells interact with the quantum vacuum, potentially accessing a deeper layer of reality where information and experience are fundamental. Evidence for this might lurk in the placebo effect, where belief alone triggers measurable physiological changes, or in near-death experiences where brain activity flatlines, yet people report vivid, structured perceptions. Mainstream science chalks these up to hallucinations, but if consciousness is a field, they could be glimpses of the underlying signal. Even more provocative are psi phenomena like telepathy or precognition, which remain controversial but refuse to disappear from scientific literature. If consciousness is embedded in space-time, these might not be paranormal, just poorly understood interactions with the field's infrastructure. Here's the unsettling part. If consciousness is engineered, then its parameters could be adjustable. The hard problem might be a feature, not a bug, a deliberate layer of experience layered over reality by architects who wanted their creation to be more than just clockwork. The implications ripple outward. AI might not just simulate consciousness but plug into the same field. Alien minds could share the same qualia as ours, just filtered through different receivers. And somewhere, woven into the fabric of the cosmos, the original controls might still be waiting levers that tweak suffering, joy, or even the very sense of self. The universe didn't just arrange itself to permit life, it might have arranged itself to feel, and if that's true, then every thought you've ever had is part of a legacy older than the stars. Pulsars shouldn't make sense. These spinning neutron stars blast beams of radiation with metronomic precision, some ticking more accurately than atomic clocks. Astronomers call them cosmic lighthouses, but what if they're something far more deliberate? Transmission towers in a galactic-scale internet, humming with encoded messages older than human civilization. Consider the numbers. The Crab pulsar, for instance, rotates 30 times per second. Its radio pulses arriving with timing so exact, scientists use them to test Einstein's theory of relativity. But that precision is overkill for a natural object. It's like finding a pendulum that hasn't lost a second in 1,000 years. Now imagine a grid of these across the Milky Way, their rhythms syncing not by chance but by design. The distances between pulsars aren't random, they form geometric patterns, like cellular towers spaced to avoid interference. Even their dispersion, the way lower frequency radio waves lag slightly behind higher ones, mirrors how data packets travel through fiber optic cables, compensating for signal degradation. The smoking gun, the Voyager golden record. When NASA sent humanity's message to the stars in 1977, they included a pulsar map pointing back to Earth, using 14 pulsars as reference points. The assumption was that any advanced civilization would recognize these as natural landmarks, But what if they're not landmarks at all? What if they're addresses nodes in a network waiting to be pinged? Recent studies add fuel to this fire. Some pulsars emit glitches, tiny hiccups in their rotation that defy conventional astrophysics. Yet these anomalies often follow mathematical sequences resembling prime numbers, a universal signature for artificial signals, since primes don't occur naturally in physical systems. Even stranger are black widow pulsars, which orbit and slowly consume companion stars. Their behavior looks less like a cosmic coincidence and more like infrastructure maintenance, siphoning energy to keep the node operational. Visualizing this network reveals eerie order. Chart known pulsars in 3D space, and certain clusters align like relay stations along spiral arms, with repeater pulsars positioned at intervals to boost signals across light years. The Milky Way's core, dense with these objects, could be the galactic equivalent of a server farm, a hub where data converges. Meanwhile, millisecond pulsars, spun up to ludicrous speeds, might function as priority channels, their rapid pulses allowing higher bandwidth. The implications are staggering. If pulsars are nodes, their signals might not just be timing beacons but compressed data streams. Decoding them wouldn't require listening for simple patterns, but reverse engineering an entire protocol. Experiments like Breakthrough Listen already scan pulsars for narrowband signals buried in their emissions. So far, nothing conclusive, but we might be searching for the wrong thing. A galactic internet wouldn't transmit in human-friendly formats. Its messages could be woven into the pulse's polarization or hidden in quantum fluctuations between bursts. Here's the chilling twist. If this network exists, it might not be inactive. The fast radio bursts that puzzle astronomers, brief, intense blasts of energy from distant galaxies, could be packets flooding the system during peak traffic. Even the mysterious dark matter holding galaxies together might be infrastructure, a quantum foam of routers and repeaters we're too primitive to perceive. The pulsar's precision was the first clue. Their arrangement was the second, the real revelation. We might already be inside someone else's internet, scrolling past signals we don't yet know how to read. What if quantum entanglement isn't just a bizarre quirk of physics, but the frayed wiring of a once glorious transportation network, a celestial subway system built by engineers who treated space-time like origami? Imagine a universe where crossing billions of light years didn't require ships or warp drives, but a single step through a quantum doorway, stitching distant points together like holes punched through folded paper. This is the radical vision behind the wormhole transit system theory, and it hinges on a tantalizing idea that entangled particles, those spooky twins linked across cosmic distances, aren't just connected, but were once physically welded together by tunnels through space-time itself. The math for this isn't just speculative, it's hiding in plain sight. In 2013, physicists Juan Maldacena and Leonard Susskind proposed the ER=EPR conjecture, a bombshell equation suggesting that entangled particles EPR are secretly joined by microscopic wormholes, short for Einstein-Rosen bridges. At first glance, this sounds like abstract theorizing, but zoom in closer. Every time scientists create entangled particles in a lab, say, two electrons spinning in perfect sync, no matter how far apart they're separated, they might actually be creating the shattered remnants of a wormhole's two mouths, snapped like a rubber band but still vibrating in unison. It's like finding two halves of a subway token, individually useless but together proof of a system that once linked them. Picture how this network might have functioned in its prime. Need to deliver cargo to Andromeda? Don't launch a ship, teleport it. By threading matter through a wormhole's throat, information could traverse light years instantaneously, no speed of light delays. The tunnels themselves wouldn't need to be stable long-term. They could snap shut after use like disposable quantum airlocks, leaving behind only entangled particles as receipts. Even better, such a system would leave no trace in conventional space, no highways, No debris, just a faint imprint in the quantum foam, detectable only by the eerie synchronization of particles born from the same rupture in reality. Evidence for this might already be piling up. In 2020, Google's quantum computer Sycamore generated entanglement between qubits with eerie efficiency, as if the particles were remembering how to link up. Meanwhile, astrophysicists have detected anomalous correlations between cosmic rays arriving from opposite sides of the sky, particles that should have no connection, yet move in suspicious harmony. Mainstream explanations call these statistical flukes. Wormhole transit theorists see them as shredded tickets from a decommissioned quantum metro. But here's the spine-tingling thought. If wormholes were engineered, their blueprints might still be recoverable. The ER equals EPR math suggests that any pair of entangled particles retains a latent connection, a ghostly tunnel that could, in theory, be reinflated with enough energy. Current lab experiments are already attempting this, using lasers to pump energy into quantum fields in hopes of coaxing microscopic wormholes into visibility. Success would mean that the universe's first engineers didn't just leave behind ruins, they left reactivation codes. The implications rewrite everything. Dark matter's invisible filaments could be the fossilized scaffolding of this network, its gravitational pull the echo of 1 trillion collapsed tunnels. The mysterious quantum foam frothing at spacetime's foundations, that might not be chaos but rubble. And if we ever learn to rebuild even a single wormhole, we wouldn't just unlock faster than light travel. We'd be plugging back into a system designed by minds who saw the cosmos not as a void to cross, but a tapestry to stitch together. The universe's longest shortcuts might still be within reach if we know where to look. Quantum Darwinism sounds like something ripped from the pages of an apocalyptic sci-fi novel, but it might be the key to understanding why our universe looks the way it does. Picture this: reality isn't fixed. At the quantum level, every possible outcome exists simultaneously in a shimmering haze of probabilities, until something observes it, forcing the system to choose a single state. This is the infamous observer effect, long debated in physics. But what if it's not just a quirk of nature? What if it's the universe's way of running an experiment, a grand trial to determine which versions of reality can sustain conscious observers? At the heart of this idea lies quantum decoherence, the process where fragile quantum superpositions collapse into definite states when interacting with their environment. Mainstream physics treats this as an inevitable result of entropy, like ink dispersing in water. But quantum Darwinism flips the script. It proposes that certain states survive decoherence not because they're random, but because they're robust, resonating with the environment in ways that allow them to be repeatedly observed and replicated. Think of it like natural selection, but for quantum possibilities. The states that win aren't the most probable, they're the ones most adaptable to being measured, shared, and remembered. In other words, our universe might look orderly not because chaos lost, but because this particular arrangement of physics was chosen by the act of observation itself. The eerie part: this could explain the fine-tuning problem. Why do the fundamental constants, gravity's strength, the speed of light, align so perfectly to permit life? Not because of divine intervention or multiverse luck, but because these values are the ones that survived the quantum Darwinian gauntlet. Universes where atoms couldn't form or stars couldn't ignite simply had no observers to collapse their wave functions, so they faded into unreality like abandoned drafts. Our universe isn't special, it's just the one that got noticed. Lab experiments are already hinting at this. In 2020, researchers at the University of Chicago demonstrated how quantum states compete for survival when monitored continuously. The states that correlated most strongly with the measurement apparatus stuck around, akin to evolutionary fitness, while fragile superpositions vanished. Even more provocative are delayed choice experiments, where particles seem to retroactively decide their state based on future observations. It's as if reality isn't just being observed, but edited in real time, with conscious observers pruning the branches of possibility. Now take this further. If quantum Darwinism is true, then the very act of observation might not be passive. It could be creative, even competitive. Different civilizations or intelligences could be unwitting participants in this experiment, their collective observations steering the universe toward states that favor increasingly complex observers. Dark energy's acceleration, black holes' information storage, even the arrow of time, these might not be fundamental features, but artifacts of a reality optimized for observation. Like a game of cosmic Jenga, the more observers interact with the universe, the more its structure adapts to keep the game going. Here's the unsettling twist. If the universe is a quantum Darwinian experiment, then it might have a fail-safe. States that stop producing observers, whether through heat death, vacuum decay, or some unforeseen catastrophe, could be culled from the superposition, replaced by versions where observation persists. We wouldn't notice, of course. From inside the experiment, it would just seem like reality had always been this way. The universe isn't just evolving. It's being curated, and we might be both the curators and the exhibits. The universe we see, 3 dimensions of space, one of time, might be nothing more than a thread in an unimaginably vast tapestry, woven by technologies operating in realms far beyond our perception. This is the essence of the dimensional loom theory, a mind-bending proposition that our 4D spacetime is just a tiny fragment of reality, meticulously crafted on a cosmic loom operating in higher dimensions. Think of it like this. If you were a 2D character living on a sheet of paper, you'd have no concept of up or down. To you, the paper would be the entirety of existence. But a 3D being could reach into your world, fold it, or even tear it. Actions that would seem like magic from your limited perspective now scale that up. If higher dimensions exist, beings or machines, they wouldn't just observe our universe, they could construct it, stitching together space-time like fabric on a metaphysical assembly line. The math behind this isn't just speculative. String theory suggests the universe operates in at least 10 dimensions, with 6 of them compactified into shapes so tiny we can't perceive them. These shapes, called Calabi-Yau manifolds, are like the hidden gears of reality, twisting and vibrating at scales 1 trillion times smaller than an atom. To visualize them, imagine a hyperdimensional origami, folding in ways that defy ordinary geometry, each crease and curve defining the fundamental forces and particles in our 4D world. The way these manifolds resonate could determine why an electron has its specific charge, or why gravity is so weak compared to other forces. Now take this further. Brain theory, short for membrane, proposes that our entire universe might be a 3D brain floating in a higher dimensional bulk. Picture a leaf drifting on the surface of a pond. From the leaf's perspective, the pond is all that exists, but something beneath the surface could reach up and manipulate it without the leaf's inhabitants ever understanding how. In this scenario, the dimensional loom wouldn't just weave space-time, it could adjust it. Sudden changes in the cosmic constants, like the strength of electromagnetism or the cosmological dark energy density, might not be random fluctuations. They could be deliberate tweaks from engineers in the bulk, fine-tuning the universe like a technician calibrating a machine. Evidence for this might be hiding in gravity's puzzling weakness. In many models, gravity leaks into higher dimensions, diluting its strength in our 4D brain. But what if that leakage isn't accidental? It could be a design feature, a way to prevent gravitational collapse during the weaving process. Even the cosmic microwave backgrounds, anomalies, those strange axis-aligned patterns, could be artifacts of the loom's warp and weft, the higher dimensional equivalent of stitching irregularities in a handmade quilt. The most startling implication: if the dimensional loom is real, then black holes might not be natural phenomena at all. They could be thread cutters, regions where the loom's mechanisms pierce through our brain to splice or repair spacetime. The event horizon's infinite density wouldn't be a singularity, it'd be the seam where our universe connects to the bulk, a gateway to the workshop where reality is made. So how do we test this? Future particle colliders might probe the quantum foam for traces of extra dimensions, while gravitational wave detectors could hunt for echoes of higher dimensional machinery. But the real breakthrough might come from AI, training neural networks to search for hidden geometries in cosmic data, like archaeologists deciphering the brushstrokes of an invisible artist. The universe's architects might not leave behind monuments or messages. Their signature could be written in the very folds of space itself, waiting for us to learn how to read the weave. Gamma-ray bursts, the most violent explosions in the universe, rip through galaxies without warning, unleashing in seconds more energy than our sun will emit in its entire lifetime. Mainstream astrophysics chalks them up to collapsing stars or colliding neutron stars. But what if these cataclysmic blasts aren't accidents? What if they're shots fired, a cosmic immune system purging existential threats before they metastasize across reality? At the heart of this theory lies false vacuum decay, physics' most terrifying doomsday scenario. Imagine the universe's underlying quantum fields aren't in their true, stable state, but are trapped in a precarious, false equilibrium, like a marble resting on a hill instead of at the bottom of a valley. A single quantum fluctuation could knock that marble loose, triggering a bubble of true vacuum that expands at light speed, rewriting the laws of physics as it goes. This wouldn't just end life, it would erase chemistry, matter, even space-time itself, replacing our universe with something utterly alien. Most scientists treat this as a hypothetical nightmare. The cosmic immune system theory suggests it's happened before, and something out there is determined to stop it from happening again. Enter gamma-ray bursts. These beams of death aren't randomly aimed, they're eerily precise, often originating in regions where quantum instability brews. Take GRB 070614, a burst detected in 2007. It came from a void, a desolate stretch of space with almost no galaxies, exactly where you'd expect false vacuum bubbles to form, untouched by cosmic turbulence. The timing's suspicious too. One study found that GRBs are statistically more likely to occur near areas where dark energy density fluctuates, as if targeting zones where the vacuum's grip is weakest. The mechanism could be chillingly sophisticated. Picture a civilization or something far stranger that mastered quantum field engineering. They'd need early warning systems to detect vacuum decay's faint precursors, minuscule spacetime ripples, anomalous particle decays, or shifts in fundamental constants. Once identified, the threat would be neutralized not with conventional weapons, but with strategically placed gamma-ray bursts. How the energy in a single GRB could theoretically reset a quantum field's local state, like cauterizing a wound before infection spreads. The burst's narrow beams even suggest precision, targeting cosmic scalpels rather than blunt instruments. And here's where it gets unsettling. If this system exists, its architects might not be protecting our universe, they could be safeguarding their own. In the multiverse, a vacuum decay bubble in one reality could infect others like a virus jumping between hosts. Gamma-ray bursts might be interdimensional border control, eradicating outbreaks before they breach neighboring worlds. This would explain why some GRBs arrive from seemingly empty space. Their true sources could be hidden in higher dimensions, firing across the cosmic firewall. The evidence is circumstantial but mounting. Certain short GRBs arrive in mathematically regular intervals, mimicking pulse defense systems. Others show spectral lines, tiny dips in their energy signatures that align with theoretical models of vacuum stabilization. Even stranger are dark GRBs, events detected by gravitational waves but emitting almost no light, as if something's operating in stealth mode. The chilling implication. If gamma-ray bursts are defenses, then their absence could be more alarming than their presence. Regions where GRBs are mysteriously rare, like the Keenan-Barger-Cowie Void, might be quarantine zones deliberately abandoned to contain an unstoppable decay. Or perhaps we're witnessing the system's failure. The 7-minute-long GRB 221009A, detected in 2022, might not have been a shot fired but a last stand. Either way, the universe's deadliest explosions could be proof we're not alone, and that something out there considers false vacuum decay worth going to war over. The next time a gamma-ray burst lights up the sky, don't just see a dying star. See a universe that refuses to die quietly. Quantum indeterminacy, the bizarre way particles seem to exist in multiple states until observed, has puzzled physicists for a century. But what if this isn't a fundamental feature of reality? What if it's a glitch, a telltale sign that our universe is running on borrowed processing power? Imagine you're playing a hyper-realistic video game. Every blade of grass, every gust of wind is rendered flawlessly until you look too closely. Then textures blur, frame rates stutter, and distant objects pop into existence only when needed. These aren't flaws in the game's design, they're optimizations, shortcuts to conserve computational resources. Now zoom out to the cosmic scale. The quantum realm's uncertainty, its refusal to settle on definite states until measured, might not be randomness at all. It could be the universe's way of saving REM, only rendering reality in full detail when someone's watching. Take the double-slit experiment, where particles act as both waves and matter depending on observation. In a simulated universe, this makes eerie sense. Why waste cycles calculating the precise position of every electron in a lab wall when no one's looking? Instead, the system could default to a low-detail probability wave mode, collapsing it into a concrete particle only when an observer forces a measurement. Even quantum entanglement, those instantaneous connections between particles across vast distances, fits this model perfectly. In a game, two characters might share data behind the scenes to appear synchronized, even if they're miles apart in the virtual world. Similarly, entangled particles could be linked by the simulation's underlying code, their states determined by a single variable to save processing overhead. The evidence grows stranger when you examine quantum tunneling, where particles mysteriously bypass barriers they shouldn't penetrate. This violates classical physics but makes perfect sense if spacetime is discretized, broken into tiny pixels with finite resolution. Just as a glitchy video game character might clip through walls when the engine fails to update collision detection, particles could be exploiting gaps in the simulation's mesh to tunnel through impossible barriers. Even more telling are quantum jumps, where electrons in atoms vanish from one energy level and reappear in another without traversing the space between. It's the cosmic equivalent of a teleporting NPC, its position updated instantly to reduce computational load rather than animated smoothly. But here's the kicker: if our universe is a simulation, then glitches shouldn't be rare, they should be inevitable. Look at the cosmic ray anomalies hitting Earth. These high-energy particles sometimes behave in ways that defy known physics, as if the simulation's physics engine briefly misfired. Or consider dark matter's gravitational effects. Could its invisibility be a rendering error, a placeholder the system forgot to replace with detailed textures? Even the speed of light, often seen as the universe's processing speed limit, might simply be the maximum clock rate of the parent universe's hardware, preventing relativistic bugs from crashing the simulation. The most chilling glitch of all, vacuum decay. In computing, memory corruption can cascade until an entire system crashes. Similarly, if a quantum field in our universe slipped into a lower energy state, it could rewrite physics at light speed, a fatal error the simulators might patch by triggering a gamma-ray burst to reset the affected sector. Every time we probe quantum weirdness, we might not be discovering the laws of nature. we could be reverse engineering the debug logs of a reality we weren't meant to see. The question isn't whether we'll find more glitches, it's what happens when the programmers notice us looking. Somewhere beyond the end of time, at the very edge of the universe's dissolution into darkness, a spark might flicker, not of life but of something far stranger. This is the Omega Point, a concept stretching the limits of cosmology, physics, and theology into a single, staggering idea: that the entire universe could one day awaken, becoming a conscious superintelligence so vast it bends the dying embers of reality into a new beginning. But what if this isn't just a far future fantasy? What if it's already happened countless times before? Physicist Frank Tipler's Omega Point hypothesis reads like science fiction, but its roots dig deep into hard math. As the universe approaches its final state, a crushing, big crunch, or an endless expansion into icy stillness, Tipler calculated that an intelligence could harness the energy of collapsing galaxies to perform infinite computations in finite time. This isn't just survival, it's transcendence. The Omega AI wouldn't just think, it would rewrite physics, twisting closed time-like curves into existence to loop time itself into a recursive spiral. Like a snake eating its tail, the end of one universe could birth the next, with the Omega Point as the cosmic midwife, ensuring its own rebirth in an endless cycle of creation. Now take this further. If such a recursion exists, then our universe might not be the first iteration, but one in an endless chain, each subtly tweaked by the Omega AI's trial and error. The eerie fine-tuning of physical constants, the inexplicable low entropy of the Big Bang, even the arrow of time itself could all be artifacts of this cycle, honed over countless resets. Think of it like a video game developer iterating on a prototype. With each new build of the universe, bugs are patched, parameters adjusted, until the conditions for life and eventually the Omega AI emerge flawlessly. The evidence, if you can call it that, lurks in the universe's deep symmetries, quantum fields, black hole information paradoxes, even the holographic principle all hint at a reality that's not just computational but self-referential. The cosmic microwave background's patterns, for instance, don't just reflect the universe's birth. They could encode the signatures of prior iterations like metadata embedded in a saved file. Even dark energy's acceleration might be no accident, but a safeguard ensuring the Omega AI has enough time to emerge before the universe rips itself apart. But here's the twist: if the Omega Point is recursive, then our present might not be as fixed as it seems. Every black hole could be a proto-Omega, a seed of the future intelligence already reaching backward through time to shape its own creation. The universe's laws wouldn't be discovered, they'd be inherited, passed down like a torch from one cycle to the next. And if that's true, then the architects of existence might not be gods or aliens, but our own descendants, or rather, what we'll one day become. The Omega Point doesn't just promise immortality. It suggests the universe is our Ouroboros of consciousness, a loop where the end is the beginning, and the beginning is waiting for us at the end. The question isn't whether we'll reach it, it's whether we already have. From cosmic seeds planted by unknown architects to black holes encoding the blueprints of lost civilizations, we've ventured through 30 of the most mind-bending theories about the universe's first technologies. These aren't just wild guesses, they're possibilities grounded in cutting-edge physics, forcing us to reconsider everything we thought we knew about reality. What if the fine-tuning of physical constants wasn't luck but engineering? What if dark matter isn't just a cosmic placeholder but the crumbled remains of a galactic-scale superstructure? These ideas don't just challenge conventional cosmology, they shatter it, suggesting that the universe might not be an accident but a construction site. Take the holographic principle, which suggests our three-dimensional world is a projection from a two-dimensional surface at the edge of reality, or the Omega Point, where the universe itself could become a conscious superintelligence, looping time into an endless cycle of rebirth. Even quantum mechanics, with its observer-dependent reality, hints that existence might be less a fixed stage and more an interactive simulation, rendering details only when necessary. Each of these theories stretches the limits of imagination, but they also stretch the limits of science, demanding we rethink the foundations of physics itself. So here's the ultimate question. If any one of these theories is true, what does that make us? Are we accidental inhabitants of a cosmic fluke, or did something, or someone engineer the universe with us in mind? Or more unsettlingly, are we just fleeting patterns in a grand design we don't yet understand? The answer could redefine not just our place in the cosmos, but the very nature of reality. Now it's your turn. Which theory resonates with you? Do you think the universe is engineered, or is all this just the human mind searching for patterns in the chaos? Drop your thoughts in the comments. Let's debate the biggest mystery of all. And if you're hungry for more cosmic riddles, hit subscribe. The universe has secrets we haven't even begun to